Hi, myself Debaparna Sengupta, Assistant Professor of Electrical Engineering Department, Techno India College of Technology, Rajarhat, Kolkata. Today, I will be discussing about the working principle of a transformer along with my colleague, Professor Rishiraj Sarker of TICT Rajarhat. Before starting the session, I will briefly discuss about the learning objectives of this video. After watching this video, students will be able to define and classify low voltage and high voltage windings, primary and secondary windings, step up and step down transformer. Explain the concept behind placing the LV winding nearer the core than that of the HV winding in concentric fashion. Explain clearly the phenomenon of electromagnetic induction, and finally explain the working principle of single phase transformer. The figure here shows a three-phase transformer. A three-phase transformer has three-phase windings. Let's first see the video, that means the animation of the three-phase transformer. So transformer is basically a device which converts or changes the voltage level from the primary side to the secondary side. In this animation, inside the casing of the transformer, three individual windings are clearly visible. This is winding number, this is actually phase number 1, this is phase number 2, and this is phase number 3. In each and every phase, there are basically two numbers of windings. One LV winding and another one is HV winding. The LV winding is placed inside the transformer, that means in the inner portion of the transformer. That means it is nearer the core, and the HV winding is placed after that, and they are placed in concentric fashion. So this is phase R, this is phase Y, and this is phase B, and each of the phases consists of two sets of winding, one LV winding followed by one HV winding, and the LV winding is placed nearby the core, then the HV winding is placed in the outward part. The idea behind this type of placement is, as the LV winding is handling a considerably low amount of voltage in comparison with the HV winding, if it is placed near the core, the amount of insulation required for the LV winding will be much lesser than that of the HV winding placed nearby the core. Therefore, it will save a great amount of insulation cost. Before understanding the working principle of a transformer, maybe it is a three-phase transformer or maybe it's a single-phase transformer, we have to first of all understand the basic concepts of electromagnetic induction. In this animation, actually, what is going on? There is a static coil. This coil is static and the magnetic field is fluctuating in nature. So, due to the relative motion in between the static coil and the fluctuating magnetic field, EMF will be induced in the coil, and this EMF will also be AC or fluctuating in nature. So this is the first phenomenon of electromagnetic induction, where the magnetic energy is being converted into electrical energy. Let's discuss the second phenomenon of electromagnetic induction. So we will gradually move on to the second phenomenon of electromagnetic induction. So this is the second phenomenon of electromagnetic induction, where the thing which is going on is that here there is a conductor and the conductor is carrying a DC current. So due to the flow of this DC current, a DC type of flux or a constant flux will be created in the three-dimensional space. Here is the case of a coil which is basically carrying an AC current. So due to the flow of this AC current into the coil, a fluctuating flux or AC kind of flux will be created into the three-dimensional space. So see, the AC current is flowing over here, and due to the flow of this AC current, a fluctuating or AC magnetic field has been created. So this is all about the electromagnetic induction. The rest of the discussion will be carried out by my colleague Mr. Rishiraj Sarker. Thank you.
Thank you, Ms. Devaparna. Myself, Rishiraj Sarker, Assistant Professor of Techno India College of Technology, Electrical Engineering Department. I will be discussing the operation of the transformer in detail. Until and unless the transformer operation of the both phenomena is discussed, we will first apply the AC supply voltage in the primary side. As a result, AC current will be flown from the primary side to the secondary side. So induced EMF will be produced at the secondary side. This is notified as capital E suffix S. A fluctuating flux, that is AC in nature, will be flown in the transformer core. This is known as phi M. Ns is the secondary number of turns. The flux is being linked with the primary as well as the secondary due to the electromagnetic induction. Here capital E suffix P is the primary side induced EMF. Turn number is capital N, so as EP actually is the self-induced EMF and ES is the mutually induced EMF. As we know, transformer operates upon the principle of mutual induction EMF. The induced voltage per turn of the primary is equal to the induced voltage per turn of the secondary, that is small ep equals to small e suffix s. Now we are going to discuss about the step up and step down transformer. The induced voltage per turn in the primary, that is capital E suffix P, is equal to the induced voltage per turn in the secondary. As the same flux is being linked, the flux is obviously alternating in nature, that is fluctuating flux, is being linked with both the primary and the secondary coil. The induced voltage per turn in the primary is notified as small e suffix p, and the induced voltage per turn in the secondary is notified as capital E suffix s. So that we can conclude total primary induced voltage is capital E suffix p equals to EP into NP, where NP is the number of turns in case of primary, and total secondary induced voltage is ES equals to small e suffix s into ns, whereas ns is the number of turn in case of secondary. Therefore, we can easily come to the point where EP is to ES is taken as NP is to NS, and this is known as a turns ratio. So according to the turn ratio, we can conclude a step up and step down transformer. In case of a step down transformer where voltage is being stepped down to a lower value, we conclude NP greater than NS. That means primary turn number will obviously be greater than the secondary number of turns. So is capital EP is greater than the capital ES. It goes for a step down transformer. Now if we come to the point for step up transformer where the voltage is being stepped up to a higher value, that is primary number of turns is less than the secondary number of turns. So as EP will obviously be less than ES. So we come to a point where a step up transformer can do.